The mandate of Innofibre is to carry out laboratory and pilot tests to reduce the technological risk associated with innovation. Our mission is to contribute to the sustainable development of Quebec pulp and paper and biorefining industry, supporting the innovation and diversification of biomass products, and also adapting pulp and paper technology. What does that mean? We can see in this scheme the whole activity of Innofibre, starting by biomass. So we work with biomass virgin or residual from forests, agriculture, recycled algae, so a lot of kind of biomass. And mainly we work on two main ways to valorize it. On the top, it's the way of transform the biomass to make pulp by processing of pulp and paper. And after obtaining the pulp, we can develop different kind of product. Example, by a fiber thermoforming process, we can develop cellulosic packaging to replace plastic packaging or other. We can also use the paper machine to develop innovative paper products. So it's the two of the process we have in pulp and paper. The other main way for valorized biomass, take the way of conditioning it. That means sieving, grinding, screening with different technology to be able to obtain a raw material that can be used for different process to obtain bioproducts, like thermoforming, which we can make wood products. We also work on pelletizing to produce material for bioenergy, or also fertilizer, or many other things. We can also take the way of extraction to extract high-value molecule from the biomass and to develop bio-based chemicals. Or we can also work on thermochemical conversion for bioenergy and biocarbon product. So, and the two main way of valorizing the biomass, as I said, cellulosic product development and bioproduct. More specifically, cellulosic products, we work on thermoformed cellulosic pulp eco-product, fiber functionalization, mechanical pulp and pulp treatment, paper machine and surface treatment, bioproduct, biomass conditioning, bio-based material and chemical, thermochemical conversion, microalgae, and also pretreatment and biorefining. About our work on the cellulosic product development. So a little bit more detail on the thermoformed cellulosic pulp eco products. So this kind of product is 3D product made of cellulosic fiber, and the idea is to replace plastic packaging. We work with different industry to develop product, and the need of the industry could be to use different kind of raw material to make a pulp and develop fiber packaging. And it could be a way to valorize different kind of unconventional biomass for pulp and paper, like annual fiber or food transforming residue, algae, seaweed, so many things we can put in this kind of packaging. There's also a lot of demand to work on functional adjuvant because, as you know, the plastic have barrier propriety that they are, sorry, barrière à l'oxygène.
Oxygen barrier.
Yeah. No. Okay, so with plastic, you can put water, oil, grease, and the content is protect from oxygen transfer, all that. So we have to be able to develop the same thing with cellulosic product, and for that, we have to work on adjuvant and surface treatment, and we work a lot on bio-based products for this kind of treatment, because we don't want to put other thing on the cellulosic product, because we try to develop more ecologic packaging, compostable, biodegradable, and also recyclable. So I think I said, do you have other thing to add?
No, that's okay. That's okay.
Here you see our pilot machine to produce a thermoformed product. We can work on different kind of design just to change the mold on the machine, and we can develop different kind of product. And we at Innofibre, we hold the chair of an NSERC chair on circular economy and thermoformed cellulosic pulp packaging. So the short name is the EcoPack chair. And you see Tariq Jabran, who is the holder of this chair. And they conduct a lot of work on thermoformed product. Here we have example of some of products we have developed. We have worked on N95 mask during the pandemic. And at the left, you can see a barquette, a food container made with cellulosic fiber and microalgae. And at the top, you can see our 3D printing machine to help us to develop the mold that we use on the pilot machine. Another field of research we work on, fiber functionalization. So we work on the chemical modification of cellulose and lignin. We work on micro and nanocellulose development, delignification, and also phosphorylation. So it's very diversified work. About the phosphorylation, we have worked a lot the last year on this way of functionalization, because we can get very diversified application with this kind of modification. We have developed frame retardant paper. We have developed hydrophobization, water absorbing material, ion exchange fiber. We have also developed nanocellulose phosphorylated products, cellulosic hydrogel also. And with this fiber modification, we have also worked a lot on the greffage of metal ion to make antimicrobial product. Here you can see pilot equipment. We work with on fiber functionalization. At the bottom, you can see nanocellulose gel we have produced, and it's not really clear the picture. At the bottom, you can see paper and fiber product. We have put the ion. Metal ion with the phosphorylating functionalization, and we have developed antimicrobial paper that are efficient against a large can of microorganisms, depending on the metal we can put on the paper. We also work on mechanical pulping and pulp treatment with at lab scale, and also with the equipment we have in our pilot plant. Maybe I can let you talk about this part.
So, like Nathalie mentioned at the beginning of the conference, Innofibre, we work in the pulp and paper industry. So we have a complete pulping process and a complete machine paper. But also in our mission is to adapt this kind of technology for new application. So here you can see the pilot reactor that we have. So of course we use it for the pulp and paper application, but also we can use it to develop new bio-based products. Eco-material, for example, and material for the construction, insulation, cellulosic insulation, and different bio-based product. We can use this equipment with waste biomass or chips. Here you can see at your right an overview of our pilot pulping process. Once again, we have different kind of technology that we adapt for the biorefining. For example, the picture at the top of your left, is it a refiner? So with this kind of refiner, we're gonna defibrilize the fiber. So we're gonna get something that is more fluffy. And with that something fluffy, we can develop, like I mentioned, eco-material. And the last picture, you can see one of our researcher, Gaston. It's a little bit flu, but Gaston is there. And is it a screw press? So again, it's a technology that we can use to dewatering waste biomass. We know that if we want to remove the water and waste biomass, we can dry, but the cost is high. So when we can use some mechanical technology, we can drop the cost or eventually do the transfer technology at an industrial scale. Here, this is a kind of biomass, and this is one of our samples that we use. So when we are at the pilot plant, we use the quantity of the feedstock. It's 1,000 kilograms and tons of material. So here's it's a good picture that represents what we use. And at the right is the pulper, when we put again, we can use 100% of cellulose or this kind of recycled cardboard from a different market that we can put in the pulper, and we had some chemical water and we get the pulp, and after we can develop some new packaging or new kind of paper.
So there's a lot of our project that involve the use of recycled material and to develop product with that. And also we work on the recyclability of material.
Yeah, and just a complement of information here, we also work with agricultural biomass and ethnic biomass also. So we have to have that adapt our equipment. It's a good challenge, but it's very interesting. And other thing that we do, we develop with industrial partners some prototypes. So we have some, yes, we have a lot of pilot equipment, and we have the capacity to connect different kind of, or bypass different kind of equipment. So is it interesting for an industrial partner to work with us to install the prototype in our pilot lab? And then we have the power, electricity power, natural gas, and our facility to develop and order pilot equipment in connection and the lab to analyze what we do. Paper machine. So I don't know. Do we have a picture of the complete? Yeah. Okay. So here you can see that a complete paper machine. So the length is roughly 250 feet. So is it the same that we can find in industrial industry? So if you go to downtown or Cougar here, you will see it's something similar, but the difference is the width. So we have a smaller one. Is it a pilot? But is Is it a unique equipment in North America and also in Europe? So usually when we are able to develop a new paper or a new packaging with our paper machine, the company, well, our partner are confident to pass an industrial trial. So we are very at the last step of the research with this kind of equipment. But again, we have a lot of surprise. So for example, we did some work on agricultural biomass. It's something new, it's something interesting, and we had to do a lot of cleanup after the trial, but we learned interesting data. With it, we did and we do and we will do a lot of projects with different kind of packaging, food packaging. Sometimes we try to use a specific paper for a specific application. You probably know that the pulp and paper industry is a lot of mill that close, but for us this means that there's a lot of challenges and interesting subject that we can work on it. And the picture at the top on your left, where we call it it's the first section of the paper machine. And we did an interesting trial with Nathalie on the micro algae. So we try to remove the water in this first step. You can see the gray box. There is a lot of gray box, but is it a vacuum where we remove the water? And again, with microalgae, there's a cost challenge to remove the water. So we adapt the paper machine to remove the water from microalgae. And then we develop a paper with cellulose microalgae. But I think that we can go with the other one.
On ne parle pas les deux, mais on en l'autre sens.
Vire la télécommande devant. Yes, surface treatment. So Nathalie talked to it a little bit. So for example, when we develop a new food packaging, imagine that you put your meat on the solid packaging, you don't want to see the blood pass through the packaging. So we develop what we call a barrier. So we are looking for sustainable barrier because we want to develop a packaging that is 100% recyclable or compostable. So we have a lab set up to measure the compostability of a new packaging, the recyclability also. We work a lot on the bio barrier. So usually the barrier agent that we use is from the petrochemical. So it's not very clean, and we use some extractables from biomass to develop new bio barrier. We did some work. So here is the pilot equipment, pilot or surface treatment that we have. There is different kind of that technology but setup. So there's three kind of application for the surface treatment on the pilot unit, and we can have different setup. We have an extruder that we can extrude some PLA. So we have some project on the bio PLA to see how we can apply it at the pilot scale. Bioproducts. So here is it again, it's pilot equipment that we have. We say pilot, but it's like more industrial equipment. So at the picture here, you can see it's a dryer. So it's with an input of 2 tons per hour. So usually we work with industrial company because we want to, we have a good expertise in the conditioning of biomass, grinding, drying, but well, we will see the other equipment in the presentation. But it's something unique that we have. We have the capacity to produce 20 tons of raw material in a couple of hours. So we don't need a week or 2 weeks for that. So it is very interesting. When we work to company, they want to develop a prototype. Usually they need maybe 2 or 3 100 tons. So we have the capacity to do it. The dryer that we have is a bed dryer. So why we choose a bed dryer? Because we can dry a lot of biomass. So we can dry some cellulosic fiber to parks or wood chip, for example. Here, two other equipment on the conditioning of biomass. So you can see at your right, is it an optical sorter? So when you put the blue bin of the road, the recycle thing, and they go at the center where there's a lot of optical sorter to separate foam, paper, plastic, compost, different kind of material. So at Innofibre, our interest is to valorize the wood, or we call it in French the CRD, the residues, the construction residues. So you do some renovation at your home, you go at the eco center to drop it. But what we can do with it, there's a lot of contaminant. So we develop a process to separate all the contaminants to the wood, and after we work to develop interesting bio-based products. And often we work with other collegial center on the plastic, for example. So we have the capacity to separate different kind of plastic, but we collaborate with others to develop newer products. So the optical sorter is a three-way output, so we can separate three different matters. And the other equipment, it's density conveyor. So it's very useful when we want to separate two matter with by density. So for example, if we want to separate soft and hardwood, it's not really interesting. But if we want to separate rocks from plastic, so it's something that could be interesting. Thermochemical conversion, so well, it's probably the same topic on what someone of you are working. It's typically the same, except that we have pilot equipment. So we have a pilot torrefactor from Hydrex Energy. The input is 100 kilograms per hour. We develop also with an industrial partner a new system of pyrolysis, so where we can recover all the heat, and we work on the development of the biochar and new application like soy amendment, pigmentation, metallurgy, food animal, and other hot interesting product. So, well, it's typically it's typically the same thing on what you are working, but at the pilot scale. Other equipment, so the palletizing system. So during our tour today, we see that we have a small unit for pallets. So it's our pallet equipment. We can produce 1 ton per hour, and we are doing project on different kind of feedstock. It could be it's not for bioenergy, but more to densify different kind of biomass and inorganic matter. At your right, is it one of our setup for the bioenergy? So we develop in this system bioenergy biocombustible, and we also have all the equipment to analyze the gas emission in the stack. So we follow the EPA methods, and we can analyze the CO, CO2, dioxin, furan, CH4, so a lot of emissions. And the other one on the top of your left is a prototype, a pyrolysis prototype that we developed. And after this project, we developed a pre-commercial system. So it's 2 times bigger than this one.
So we work also, as we said, on microalgae. More specifically, we have worked on project mainly on wastewater valorization. So we start to work on that in collaboration with the University of Quebec in Trois-Rivière, and it was in 2011. And the first project was to install, to look at the feasibility to install a microalgae production in co-location with an industry by using their wastewater for the cultivation, and after convert the biomass in the biofuel to use at the industry. Along the past year, we have conducted different kind of projects, but mainly for the wastewater valorization, but also to develop bioproduct and biofuel based on microalgae. The particularity of the work of Innofibre is because the production of microalgae is costly, and the biofuel obtained from microalgae is not cost competitive with the petrol base. It's important to continue to work on the process, and one step of the process is the harvesting, as Jean-Philippe said, and it's a costly step in the process. And it's why we start to work on the adaptation of pulp and paper equipment for the harvesting of microalgae, because the pulp and paper equipment are already upscale and already designed to remove water from fiber. So it was a good way to adapt something for the microalgae harvesting. We have also worked on the hydrothermal liquefaction of microalgae biomass, thermochemical conversion of humid biomass. So we have done work on that. We are specialized on the culture media development based on wastewater and optimization of growing condition. We also scale up, as I said, the harvesting process with pulp and paper equipment. We work on quality testing of algal biocrude produced by hydrothermal liquefaction. And we also work on the extraction and quantification of molecule of interest. Here you can see our pilot tank that we have in the pilot plant. It's a 10 cubic meter tank, and it allows us to produce enough biomass to test pilot scale harvesting also. We have a lab to maintain all the strain. We work with different strain of microalgae depending on the project. We can. Another field of research, we work on pretreatment and biorefining. So we work on the pretreatment of new cellulosic biomass by physical, mechanical, chemical, thermical, and biological process, and also for various applications. We work we have worked on different kind of biomass, as we say, the agricultural residue or wood, or and we have made work on impregnation, acid alkaline hydrolysis, enzymatic hydrolysis, also steam explosion, cooking with hot water. We have pilot equipment to work on the pretreatment and fractionation of biomass. Another field of work at Innofibre, bio-based material and chemical. So it's a big field. We work on with different kind of biomass, and usually, as I show in the scheme at the beginning, we take a residual biomass. A partner comes to us and say, "Oh, I have this biomass. What I can do with that?" So we take it and we assess the potential of turning it into pulp for fiber product, and we also assess the way of conditioning to develop bio-based material, but there's also the way of biochemical. So we can make extraction by different process, solvent-based, or also for extraction we have adapted pulp and paper technology. to extract secondary metabolite from biomass. And also we have developed a very effective platform to assess the bioactive potential of this molecule, mainly antimicrobial propriety or antioxidant. So we can extract the high-value molecule from biomass, make a high-value product with that, and the biomass, we can convert it in the biomaterial. Biomaterial, I mean, like thermoformed wood product. We can like the picture you've seen before, we can develop a molded product. For this is an example of a project we have conducted with the construction with the residue. We have developed a skid for transport. So it's a residual biomass that we.
And for example, just in this project, what we did is that at first we optimized the process of the conditioning of the biomass, so how we can separate the plastic and all the contaminants. After we developed the recipe, so the particular size, what is the quantity of bioadhesive that we have. We developed also the mold, so and then we start to doing some panel at the pilot, lab pilot, and to develop the recipe. And once we get the good or an interesting result, we go at the press, heating press to produce a skid. And then we produce approximately 30 skids like this one. And one of our partners in this project was an end user, so it was interesting for him to use this kit that they developed. And of course, there is some modification that we do, but the project still continue, and now we have a second prototype of this kit. Technical assistance services, so it's quite similar to what you do here in your lab, but it's more in the pulp and paper industry. So is it an expertise that is tough to find? So Innofibre, it is a team of 20 technicians roughly, and we have all the equipment to analyze the pulp, the cardboard. We also have an analytical lab for different kind of biomass. So why work with us? So accelerate the technology development. We have access to the hard equipment, access to the research ecosystem. So of course, when we meet the industrial partner, it's very interesting to present them, but I'm pretty sure that you know how this. And we develop sustainable collaborations also. Opportunity at Innofibre, so like Jean-Michel said at the beginning of the conference, we're still looking for new talents. So we're looking presently for 2 researchers, one for the paper machine and another one in the field of the thermoforming products. We're also looking for technicians. We do a lot of collaboration with other collegiate centers, but we're also with university, UQTR, Université Laval, for example. So the collaboration, our project is different. Sometimes is it possible that we do a project with an university and the supervision, it's one of our researchers at Innofibre and a professor at the university. We can work, we have one industrial partner and we can work with the university. University, sometimes it's more at the lab scale. Us, we are more at the pilot scale, so like this, it's easy, like we said, that the result that we get at the lab, we can try it in the same week at the pilot scale. So like this, we can accelerate the development and the technological transfer. And well, if you're interested to contribute to social issues, to reduce GHG, valorize waste biomass, and to have a better world by your knowledge and your work, so you're welcome to come to visit us We are in Trois-Rivière, 1 hour, 1.5 from here.
Not so far.
That's it. Good.
Thank you.
Thank you very much.
We have time maybe for 1 or 2 fast questions for the speakers. So we have 1 or 2 fast questions.
Are you operating bleaching process?
Bleaching process? We have a system for bleaching process. So we have a pilot lab reactor. It's a 20-liter reactor where we can do some bleaching process. And we have another reactor. It's 300 liter, I think. So yes, we did some work on the bleaching.
So do you have a pulp system in your lab, like you chip the wood, make the wood chips and pulp, or to extract the lignin and the cell walls? And the lignin that you studied to make some modification, do you guys extract from the black liquor to analyze, or you buy the powder?
Well, it depends what is the project, but we have the project on the fragmentation of the biomass. So in the first step, we can do a cooking to extract the new cellulose when we get the cellulose and the lignin. And after, we can separate these both components with the extruder. So is it something that we can do? About the lignin, it depends on what is the project. So we develop bio-based project with lignin. And so in this case, we'll buy some lignin on the market because the objective is to be able to produce it. And other project is that we work on the valorization of black liquor from the pulp and paper mill. Then there's a lot of challenge again, but we can separate the contaminants and as is the liquor, the black liquor, or try to separate the lignin.
So you have sulfur in the sample, in the lignin?
Yeah, well, yes, we did some work on it. All the project that we have is it with an industrial partner, so we are needed to share what is the result that we get and what is the topic. But yes, we work on it.
Who is this in? Sarita or?
Yeah, so when you mentioned that you guys do surface treatment for the packaging, I was wondering, is that surface treatment based on biomass? Like, do you get the like precursors from biomass?